second. Are Alastair Collins and Steve Watts. Alastair Collins is the Chief Executive of Davis Langdon and Shea International's Global Board and Managing Partner of the International Group. Steve Watts is leader of Davis Langdon's Tall Buildings Linkage Group, heading a global network of high-rise specialists. And now our speakers.
Hi, thanks very much. For those of you who were in this morning's session, I think you'll have picked up there's a very strong thread about sustainability being a lot more than just about green buildings. That's not to say that green buildings aren't important, but if organizations as influential as Ctbuh are going to embrace sustainability as an agenda, then it does, as the speakers this morning indicated, need to be considered in a much more holistic sense. I'm going to give the speaker a very short time. I'm going to introduce you to Steve Watts. As was mentioned earlier, Steve leads our International Tall Buildings Group and is a renowned expert in the subject. I'm just Irish and I can talk about anything. So the other refreshing thing is that this is the only slide you're going to see from me. I don't believe in death by PowerPoint, so it's just going to be a bit of a chat and a bit of an introduction. This particular session is sustainability, the bottom line. And I guess a couple of years ago, no organisation would have been adventurous enough to put something like that into a program, because bottom line indicates that there is some sort of commercial proof that attaches itself that by going green or embracing a sustainability agenda, it can actually make bottom line sense. But in the overall economics of tall buildings today, this is an emerging truth, in fact an emerging proof. I've just come back from Australia, where there was a remarkable talk given by one of Australia's leading commercial property developers, just saying that not embracing a sustainable agenda is an impossibility. And I heard a similar thing from a developer client in Singapore back in October. So here are commercial people realizing that if they wish to remain competitive, that demonstrable sustainability has got to be part and parcel of their overall offering. But each of them recognized, as the speakers this morning recognized, that it's not any one thing, that sustainability isn't even a jigsaw puzzle. It's like a Rubik's Cube, that like a jellyfish has made it, because it's almost an impossible thing to define or refine or put into particular context. So I hope that's what Steve is going to do into the particular context of tall buildings. But one of the things that emerged from the talks that other people have given was the important linkages that we as experts or advisors in the built environment must be concentrating on, is the definable linkage between embodied energy that it takes us to create the materials and components essential to constructing our buildings. And one of the speakers this morning, Lee Morris, made mention of the fact that we are ever asking for more and more energy, and that China, being the largest miner of coal in the world, also uses all its own coal to the extent that it's now the largest net importer of coal in the world, primarily from Australia and from South Africa. So that, if you think about it, is not really a sustainable cycle from the point of view of using that coal to generate energy, which is not actually clean in terms of its byproducts. And we in the construction industry, if we rely on things like glass and steel and aluminium as our materials of choice, then we have to recognize that aluminium is not particularly friendly toward the planet, and that 80%, if any of you here happen to be the owner of an aluminium smelting firm, 80% of your gross operating cost would be in energy. So there are things like that that are very, very difficult to square. Then there's the linkage through to construction efficiency and control of construction waste. It's always been fair game. You know, construction industry produces waste, so what? We just sweep it up, cart it away, and create more. So again, that's part of the sustainability cycle, reducing construction waste by considerable amounts in order to bring that under control. Then the operational efficiency of buildings. The developers pointed out there's not much point in us working to create an energy efficient building if people then use that energy efficient building inefficiently. So there was an education process required there. But the real clincher in the whole piece productive efficiency of the space that was created, and I'm referring now particularly to commercial offices, that if people weren't educated to engage with the people and develop really, really good socially focused agendas which were corporately responsible, they wouldn't get the best out of their people, they wouldn't get the best out of their space, therefore you wouldn't be creating this cycle of value which would come into making them realize that you could pay more for well-designed green space because you're actually going to get more out of it in terms of the productivity of your space. I mean, our business, 60% of our gross operating cost goes to payroll. And if we get only 10% increase in productivity out of that as a result of having a more benevolent working environment, we pay for our rent. So it's a very, very simple equation. Last word from me, my personal hobby horse for the moment, because I tend to change horses every now and again, is infrastructure. It was mentioned this morning by speakers. I quite frankly think that any agenda that embraces green design or sustainability as a whole toward the built environment that isn't looking at infrastructure and master planning is quite frankly wasting its time. There is no point in putting the greenest building in the world on either redundant, insufficient, inefficient or broken infrastructure. One of the speakers this morning mentioned a couple of cities, Mumbai, Sao Paulo, Mexico City. There could be an argument there that their infrastructure is broken beyond repair. So there has to be some fairly drastic thinking, some very innovative thinking as to how those cities are going to employ multi-millions more. And not just the millions more of the official population, but the millions more of the unofficial populations that are flocking to these cities. You can only load a thing so far until it breaks, and then in kicks Young's modulus, and it can never return to its natural state. So I think those are the points I would like to leave Steve to challenge when he starts putting tall buildings on top of infrastructure. And one final point is to say that infrastructure for me means more than just the platform that supports the built environment. It's very important to invest in the social aspects, health, education, and safety. If you look at the latest poll of the safest places in the world to live, they've all got brilliant infrastructure, and they all feel safe. So, with that in mind, over to Steve. Make us feel safe. Thank you very much indeed.
Thank you, Alastair. As Alastair suggested, I mean, I'm going to be talking about tall buildings, but it's very much against the background of the part they play in their wider environment. Thank you. So if you've come here expecting me to talk about the premium you have to pay for biomass boilers, I'm afraid you're going to be surely disappointed. Patterns of density play a large part in defining our cities, and that is i.e. the location and the height of buildings. And we can see, and we've seen examples this morning of very different situations where we have established as opposed to emerging or re-emerging cities. And just taking the transport aspect of infrastructure alone, we can see very different scenarios here. The first where growth is very much related to private, i.e. car transportation, and all that implies. And the second where the growth of the city is served by and reliant upon public transportation. London is a great example of that, but anyone who's been to London recently will see that it's creaking. It needs a lot of investment in its infrastructure just to support its existing living and working population, never mind the projected figures. Thank you. Our good friends at ADAS have created this model that simulates how a city might grow around a central office tower, and this first scenario shows that's related to growth along car routes. So you can see the routes in blue and how that growth is lineal along those main arteries. And you can see examples of that in some North American cities, and arguably here in Dubai too, with linear development, albeit high-rise, along Sheikh Zayed Road. This second scenario demonstrates the alternative growth pattern, which is that related to public transport. And that could relate to a more mature city like London, for example. And here the growth is much more organic. The spaces within a more central hub are filled in before horizontal sprawl takes place. And in a way, those simulations sort of show how a tower development requires and stimulates services, whether they be public or private transport, or a mix of other uses, for example, leisure facilities or residential spaces. And really, they serve to prompt questions about the sustainability of a building, in particular a tall building, and more particularly the city in which it's located, on issues such as the efficiency of infrastructure, on congestion, on diversity of use, and so on. And the point is, I'm not a transport engineer, nor am I a city planner, but what I'm hoping to just introduce here is the idea that the sustainability of a tall building is related just as much to its environment as it is to the building itself. The tower and the city support each other, and through that relationship and the tower's ability to take advantage of existing and developing infrastructure, then it reaches far beyond its envelope. The asset life cycle is split into three separate, very discrete stages: construction, use, and reuse or redevelopment. And the more inclusive of the sustainability statements, which is related to economic, social, and environmental issues, or the 3 Ps of profit, people, and planet, we can actually see that in terms of building projects, not only tall buildings, but building projects in their wider sense, they tend to disaggregate those two concepts. And the important thing here, I think, is that the focus is very much on relative short-term profit, which is that red dot at the beginning. And that profit and that focus is much sharper for tower projects because of the greater challenges and pressures on the bottom line for developers. And who can blame developers for looking at the bottom line with all those challenges that they have to overcome? And that profit perspective means that, to a large degree, we pay lip service to issues such as life cycle cost, to business efficiency, to a whole host of other things. And what it does require is an appreciation of capital cost drivers and the usual and more traditional QS metrics of wall to floor and net to gross ratios, of the weight of the structural frame, and our favourite bottom line, the cost per square metre of the shell and core building. And what's interesting in all this for me is that sustainability actually occurs quite low down that list of capital cost priorities. And just take London for an example, where the towers which are currently set to change the skyline of that city, you know, the Herons, the Shards, the Broadgate Towers of this world, the most that any of those projects is investing in sustainability measures or renewable technologies is between £2 and £3 million. Now that represents less than 1% of their total construction cost and an absolutely tiny fraction of total development cost. So, the first point to emphasise is that we need somehow to move that perspective from the profit circle to embrace the social and environmental circles too. And as I said earlier, you know, life cycle costs, energy usage, business efficiency, as Alastair mentioned earlier, if you take the total cost to a business of occupying a building over its lifetime, 85% of that is staff related. And what about infrastructure too? The current driver is very much legislation, and that's backed by international and national policies, which then filter down into local guidelines and regulation. And there's a whole host of them. In the UK alone, we have the Building Research and Establishment Energy Assessment Method, BREEAM. We have Part L of the building regulations. We have codes for eco homes. We have landfill directives. We have a whole host of directives, and it's a bit confusing. Sorry, I'll just go back to that. So, although the stick is very much legislation, it's a bit of a soft stick, and we can't really fault the policymakers for that because no one really has a coherent framework with which to assess sustainability. If we just go back to the triple bottom line and how we might integrate that into the various stages of a construction and asset life cycle, what really needs to happen is that those circles embrace the whole building life, starting with the energy used to actually manufacture the components that fit into the building from the outset, the embodied energy, to how that building might be reused in 50 or 60 years' time. And we'll see later how the impact that can have. So somehow that all needs to be unified. I think the other thing to say here is that with time, the impact becomes greater. The challenge being that the metrics tend to become more implicit than explicit, so somehow we have to overcome that hurdle. And here's just one example of how that impact does increase with time. This was a study we did for an office tower in China, which in summary terms shows that the total cost of operating that building is 6 times greater than the cost of actually producing the building in the first place. That was costs. This is environmental impact. This is another study that we helped the University of Hong Kong with a year or so ago. It covered a range of buildings, and one of which was this office tower that this pie chart represents. What it did, it created an environmental impact unit of measurement called a Hong Kong Eco Point, which covered a whole range of impacts from climate change, acid rain, photochemical smog, and so on. And for me, the important message from this pie chart is the relative insignificance of construction in environmental impact, and the absolute significance of operations and repairs and maintenance. If you take that green and that yellow, those yellow pies together, that's almost 80% of the total environmental impact of the building over its lifetime. You say quantity surveyors can't do graphics. Sustainability is a critical, but it's also an evolving subject. It's characterised by a certain amount of circular reasoning, some inconclusive evidence, and that complexity and the range of inputs that we need to take account of means that sometimes it feels like trying to nail a jellyfish to the wall, hence the graphic. It's also subject to a number of paradoxes, but in a sense, they really serve to show that we need to take a longer and a wider view. My favourite paradox is actually one that we looked at previously, last year, and it was a study that was carried out by an American company on the green credentials of the automotive industry, and it was gleefully picked up by a UK motoring magazine, which showed that if you actually assessed cars in terms of sustainability and looked at their whole life cycle from design, manufacture to operations, and importantly, recycling. In the UK, of the 96 cars that were studied, the Honda Civic Hybrid and the Toyota Prius were ranked 73rd and 74th, respectively. And now those are cars which are shown to have some of the lowest CO2 emissions available of any new car. And the most sustainable car in those terms was the Jeep Wrangler. And that was because of its simplicity of design, its ease of recycling, and the longevity of its materials. In a way, we need to apply that same perspective to buildings. We can't just focus on capital costs, we need to look at the whole life cycle. The construction industry is often bemoaned to lag behind others in terms of its pick-up and use of technology, but we do actually have some pretty clever tools at our disposal. what we don't do is actually employ those tools early enough on in the process. But these are tools that actually can model some pretty complex relationships. But for me, what I would suggest we need is some framework where we can actually use those tools, put it within a larger framework, a larger model, just so that we can actually assess costs, energy and environmental impacts of a building, of a tall building, from start to finish. ADAS and ourselves have started actually developing quite such a model. We've been working on it only for 3 months, but we've been working hard at it, and ADAS in particular are largely responsible for what you're seeing here. We've started by taking our tall building cost model, which reflects an iconic tower in central London, and thought, well, how can we assess the impact, for example, of height, which is what this animation shows, not only in terms of capital costs, which is what those bars in the centre, bottom of the screen show, and those are the substructure, superstructure, MEP, lift, etc. elements, but also operating costs. We're also interested to know how all of those factors might be impacted by shape and size of floor plate, and whether tapering a building has any significant impacts across all of those issues. Again, just looking at alternative shapes, whether it's circular or oval, what impact does that have on the various capital cost elements, and also energy usage? One that tends to characterise a traditional tension between architects and QSs or developers is floor-to-floor heights, and often developers try to squeeze that sandwich so that they can accommodate more net floor area into a building. But do we properly analyse it when we take that decision? Do we look at the impacts on the environmental strategy of the building? Facades, an absolute key cost driver in towers and a critical part of environmental strategy. Would it be worth investing more in methods to overcome solar gain in order to reduce energy costs? These are the sorts of things that we're just starting to look at, and we're in the process now of strengthening and checking the data inputs, but also questioning some of the key relationships which are being shown. As we heard this morning, oil is currently over $100 a barrel. If it became $200 a barrel, what would that do to the energy cost of a tall building? And, importantly, what effect would that have on renewable technologies, which also take energy to manufacture them? There's a whole series of cost-benefit analysis that we need to undertake, and we actually can do it. One of the barriers at the moment is just a lack of information, or a bit of inertia in actually going out and grabbing that information. But if we had a model and a framework which we can actually see works and we can actually test these relationships, then that would encourage us all to actually go and get that information. And that lack of information is one of the reasons why a lot of people quote the vicious cycle of inertia as being the status quo at the moment. Again, I think, just going back to the point about legislation, if we had a framework that would make it clearer, that would actually remove some of the confusion and give a longer and wider view and show just how the impact of a tall building, for example, isn't just about the building. It isn't about putting more steel, which creates more embodied energy. It's about the wider impacts of the way it sits in its environment. And actually, I was told just 2 days ago that a recent study by the US Green Building Council showed that average nationally, a US office building, there is almost 2.5 times more energy used in its workers commuting to and from that building than there is in the actual operation of the building itself. I hope I haven't given any answers. I understand that. The bottom line for me is, someone came to me now and said, how much do we have to pay to create an eco tower, a green tower? I would say, I don't know, because I don't actually know what a green tower is. I can tell you how much you'd have to pay to go from very good to excellent in a BREEAM rating, or from silver to gold in LEED, but does that actually represent a green building?